Hey, I'm just going to quickly share the answer key that I produced for the Chapter 10 study team test. On question number 1, I started with area equals 4 pi r squared, and we were asked to solve this for r, the radius. I began by dividing both sides of this by 4 pi. So it ends up with a surface area divided by 4 pi is r squared. And then I went ahead and took the square root of both sides, or raised both sides to the 1/2 power. And when I do that, I get both the positive and negative root, but only a positive radius would make sense. So it is just positive the square root of a over 4 pi. Be real clear, notice that the 4 pi is in the denominator, but it's also inside the radical. So make sure your radical is large enough that it's very clear that you're taking the square root of the whole thing, a over 4 pi. If you wanted to simplify this, because 4 is a perfect square, you could pull it out and write this as a 1/2 here, but that's totally not necessary. This is a perfectly fine answer. On the next question down below, this data set had 9 points in it, so that means that it's odd and there's one value in the middle, and it's this number 14. So 14 is my median, and if I look at the lower half of my data, there's 2 values in the lower half, and the average of those is 8. There are 2 values in the upper half, and the average of those is 34. So my minimum value is 2. The Q1 is the number 8. The median is at 14. Q3 is at 34, third quartile, and then the max value is at 43. By the way, on this scale, each of these lines is worth 2, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's why why these things are where they're at. Question 3A, it says write a function that matches the graph at right, and for this particular function, it had a y-intercept at 8, and it was down 3 over 1. So that looks like y equals negative 3x plus 8. The next one, I could see the 0th term here is 2. That's nice, right? When x is 0, y was at 2. And as I proceeded forward, at 1, I hit the value of 6, and at 2, I hit the value of 18. So as I move forward, I'm multiplying by 3. So it's really easy to see the multiplier and the 0th term in this function. So it is y equals 2 times 3 to the x power. On the next question, we were asked to write, it says write an equation of any line parallel to the line containing the points 6, 8, and 12, negative 6. And you can see I'm calculating the slope here. So I've got negative 6 and then minus the positive 8 over 12 minus the positive 6. So my numerator is negative 14 and my denominator is positive 6, and that simplifies to 7/3. So I've got a slope of 7/3. And I wrote f of x equals negative 7/3 x plus anything except for 22. And I actually went through and I calculated what the y-intercept would be for this. And it's really important that you not say 22, because I think parallel and being the same line twice is kind of a different thing. So a parallel line is not the line that it is. So as long as you put anything except 22, you were fine there. Let's see. On this next question, let me see if I can maximize this. Whoops. That's better. So on this question, you're given a function. This is the function f, and this curve basically describes all the inputs and outputs. And the first question is, if negative 6 is your input, in other words, I'm sitting here in the domain, right, are all my input values, and if I put negative 6 into the function right here, what does it produce as an output? And that's given by the curve. So at negative 4, you can see it looks like it's going exactly through positive 2. So when x is negative 6, this function produces an output of 2. Question 6 says, what value or values of x will make f of x equal 0. So in other words, what values of x will produce outputs of 0? And you can see there were 3 of them. When x is -6, this curve is hitting y is 0. And then again, when x is 1, it's hitting at 0 again. And then when x is all the way over here at 8, you can see it's producing 0. So -5, 1, and 8 all produce outputs of 0. And I think I was fine if you just gave me a single one. However, be aware I may ask for all of them, but I was just happy that you maybe produced at least one of them. Number 7 was a highly missed problem. And when we square a binomial, we're literally multiplying it by itself. So this is just the definition of what it means to square something. To square x minus 4 means to multiply x minus 4 times x minus 4. And it might be helpful to use a generic area model. For me, a binomial times a binomial is pretty simple to do, but if you're not sure where this comes from and you're unsure about it, please set up a generic area model. It'll take you a couple seconds, and you'll be much happier with the answer you produce. On this one, B, I've got 3x and I'm multiplying it by the quantity of 2x minus 1. So I'm just distributing the 3x to each of the terms inside of the parentheses. So this becomes 6x squared minus 3x. On C, I did use a generic area model off the page. And so it's like rectangular grid. And across the top, I had 1, 2, 3 columns. And on the side, I had 1, 2 rows. And I had an x and a 4, and then across the top I had a 3x squared, an x, and a -1 as my columns. When I went down and I found all the areas in each of those rectangles in the generic area models, I combined like terms, and I got 3x cubed plus 13x squared plus 3x minus 4. Question D is x squared plus 3x plus 2. Let's see, for 9, I may have or patty paper available for the study team test, but some of these things, like a rotation of 180 degrees about the origin, that's equivalent to this rule, right? X, Y has just become the opposites of what they were. So if I'm trying to figure out where A goes, A was at -4, -2, and if I take the opposites of each of these, A goes to +4, +2. This is a different thing. This is not the rotation. This is another problem down later. For B, it says if this is reflected across the line y equals x, give the coordinates of B prime. B prime should be at 1, -3 if I'm reflecting across the line y equals x. And for C, it says it's translated by this rule, so my x values are increased by 4 and the y values are increased by 6. So the point C should end up at 4, 2. In question 10, if I solve that system using substitution, I ended up getting -2, -5. This B, it is definitely less than, so we're saying that this absolute value is constrained by it can be no more than 14, right? It has to be less than or equal to 14. So it'll be those things in between an upper and a lower bound. So I wrote this as, and I could flip this one, but x's are bigger than -7/3. So if I'm thinking of a number line, I'm starting at -7/3, and then I'm going all the way up to 7. 7's the largest, and this is everything in between those two. If this doesn't make sense to you, please ask me in class to show you another one of these. Make sure you have this very clear in your mind how you do this, and I apologize for not showing the work here. For C, I needed to know how to square this binomial, so you can refer to the previous problem, but literally I multiplied 2x plus 1 times itself, and then plug that in there and then simplify it, and I ended up getting x is 7, and it works perfectly when you plug it in. In D, this is saying the absolute value is greater than a value 7, so it's going out to the left or right. So this is clearly a greater situation, so it's a great or. And when you solve this, you should get that x's are either going to be less than -1, so they're going to shoot off to the left. X's are smaller than -1,
Or on the right-hand side, x's are going to be greater than 9/5. So the values in between those won't work, but anything going off on to the left or right will work for this problem. This inequality is x's are those things that are larger than -2 or greater than 4. X's are between that. Notice when I write this down, right, I'm saying the smallest is -2, x is somewhere in the middle, and the largest is the 4. These three things, elimination, substitution, and most of you identified this as equal value. I just want to point out that both of these are ways of writing 3y. So it's kind of cool because these are both equivalent to 3y. I can literally set 2x minus 20 equal to 8 minus 4x because they both equal 3y. And it's kind of a nice take on the equal values method, right? These are both equal to 3y, so this 2x minus 20 has to equal x, or 8 minus 4x. Let's see, moving on. In this problem, you can see that if I've got equal intervals, I'm producing an equal change in the output here. So when this interval is 2, I get 4. Over here where the interval is 2, I get 4 again. If the interval is 1, I'm getting 2. But notice these are all equivalent slopes, right? 4 divided by 2 is 2, 2 divided by 1 is 2. So the speed here is 2 miles per hour. And then finally on question 14, we completed this two-way table, and we had two variables, boy, girl, and brown hair, blonde hair. You were given some of the values here, and I completed the table by just using the fact that this marginal row has to add up to 175, and the marginal column has to add up to 175. And then from there, I'm just picking in and finding these values. Statement B, or part B, says, if a student is selected at random from the 175 students, what is the probability that the student will be a boy with brown hair? Well, I only had 63 boys with brown hair in this sample, so if I'm selecting from this group, it would be a 63 out of 175. And the final question there is, what is the probability that a student will have blonde hair given that the student is a girl? So this is a restriction right here. I've given information. I'm given that the student is a girl, so I'm looking at this group only. And blonde hair was 42 out of the 79. So 42 divided by 79 is about 53%. And again, please note that that's kind of, many of you wrote down 175 there, but the thing to focus on is we're given the fact that the student is a girl. So given that the student's a girl, we're just talking about these 79 students. Those are the 79 girls. So we're looking at 42 divided by 79. So those are the answers. You can check your work on your own study team test. And again, if you have questions, please talk to me in class. The other thing I'm going to be doing is posting a couple additional questions in the SWAY that the study team test linked to. So if you look there, you'll see some other questions that are possibly could be swapped out for some of these, or on the actual individual test. This is Mr. Roberts. Goodbye.